Okay, so we'll see how to solve a Cauchy-Euler differential equation. First, what is a Cauchy-Euler differential equation? I'll be considering a second order one instead of taking a generalized one. It would be of the form x squared d squared plus some constant into xd plus some constant into y is equal to q of x. What is d? D by dx, as all of us know. Now let me consider. Okay, I will just take one assumption. That is, I will start with one assumption. What that assumption is let x is equal to e power z is what I will take. I'll apply log on both sides. So I'll be getting z log e base e, right? So z value would be log x. dz by dx value would be what? 1 by x, right? Now, I already know that dy capital D into y is equal to dy by dx. Now clearly I can see y is a function in x. X is a function in z. So I'll be right. Y will also be a function in z. So I'll be using chain rule to write like this. dy by dz into dz by dx. I'll be cancelling out dz and I'll be getting dy by dz. It's like that. But actually, it's d by dz and d by dx are differential operators. So they'll have a different meaning. Anyways, now dz by dx value from this is 1 by x into dy by dz. Okay. This is nothing but capital D1. Now I will write theta is equal to d by dz. I'll assume again. Then what will happen? I'll take x this side. So x d dy is equal to theta into y. Is that fine? I can write like this, right? Now this value I have already got. By the way, what exactly I'm trying to do in Cauchy-Euler is a variable coefficient differential equation, unlike a constant coefficient one, variable coefficient differential equation. What I'm trying to do using this transformation, I'm trying to transform variable coefficient to a constant coefficient one. You'll be observing it. You'll be observing it, how it gets transformed to a constant coefficient one, right? Next, what I should do is I'll be considering d square y. How will this look like is d by d square y by dx square, actually d by dx of dy by dx. Now if you see dy by dx, whatever is there, this is completely either in terms of x or z. So what do I do is I'll be rewriting this as d by dz of dy by dx into dz by dx. I'll be cancelling out dz and I'll be again having d by dx only. Okay. It is like that actually. 2 by 3 into 3 by 5 is 2 by 5 kind. But then of course when I'm operating, things are different. When I'm taking it as a differential operator, things are different. Now I'll be dz by dx value anyways, I know it is 1 by x, which I'll substitute later. But then I will look at this. What that would be? D by dz of 1 by x into dy by dz. I'll be using UV rule, of course. D by dz of 1 by x would be what? 1 by x derivative would be, x is a function in z, right? So derivative of x with respect to z will have some value, right? Minus 1 by x squared. Okay. This would be as it is. dy by dz plus 1 by x is as it is. Now this one I'll be differentiating. What I'll be getting is d square z by dz square. Okay, that's it now. No, one second. D square y by dz square is what I'll get. D square y by dz square is what I will get. Okay, so dy by dx is this term. And then I have 1 by x here. So finally what I'll be getting is, for this term, I'll be getting 1 by x into 1 by x. So both of the terms will have 1 by x square in common. 1 by x square is common for both the terms. D square y by dz square minus dy by dz. If you don't understand All these manipulations also, it is fine. I'll tell you what to remember. D square y is equal to 1 by x square into d square y by dz square minus dy by dz. I know I am notating d by dz as theta, and x square I will take towards this side. So I'll be having x square d square y. This is equal to theta square y minus theta y. It is nothing but theta into theta minus 1 into y. I know what is theta. It is d by dz. That's how I will be solving it. Just see here. This value, the variable quotient 1, has been replaced by x square d square y is being replaced by a constant quotient 1. D into d minus 1 into y kind. Okay? Yeah. Now, let's do one problem on Cauchy Euler so that you will understand. Okay. Solve d square. What I should consider x square d square for the solution. What I should consider, what I should skip, what I should write out of this whole thing, I will just tell you. Now, what I will do is how I will start the solution. Just see here. First I'll write it is a Cauchy Euler equation, Cauchy Euler differential equation. I'll write it. Then I will go with the substitution. X is equal to e power z. I also write z is equal to log x. I also will write dz by dx is equal to 1 by x. After this, I'll directly come to the steps. What are those? X dy. This would be what? Theta y. X squared d square y would be what? Theta into theta minus 1 into y. What is theta? D by dz. What is d here? D by dx. Okay. So directly I will proceed with the substitutions. Theta into theta minus 1 minus this first term value is this. Second term value is theta because y is taken common plus 1 into y is equal to log x. Log x is what? Z. Okay. So what I will have will be theta squared minus theta plus 1 into y is equal to 0. Once it is transformed to constant quotient 1, I'll go with my routine procedure. Auxiliary equation is m square minus 2m plus 1 is equal to 0. Roots are m is equal to minus 1, 1 comma 1. Okay, not minus 1. Roots are m is equal to 1 comma 1. So I know what the solution is. 1 comma 1. So yc, how I will write? Yc in terms of z would be c1 plus c2z e power z would be the solution, right? In terms of z. At the end, I will transform it to in terms of x. Okay. Now for yp, what should I do? Yp is equal to 1 by d minus 1 whole square. F of d into what's there on the right hand side? It is z. It is not d, I'm sorry. This is theta. Why? Because theta is d by dz, right? Now what I should do? I should rewrite it. What that is I'll take a minus sign common. Of course, it will become plus only because it's coming out of the square. I'll be rewriting it as 1 minus theta whole square power minus 2 into z. If you remember this expansion, 1 minus x power minus 2, both are minus. So if you remember the expansion directly, right? The expansion would be like 2x plus 3x square kind. It would be like this. So write accordingly 1 plus 2 theta plus 3 theta square. Of course, theta is what? Theta of z would be what? D by dz of z would be 1. Anything else, theta squared of z would be 0. Cube also would be 0. So till which term I will write? I will write only till second term. Okay. So 1 into z would be z. Theta of z is 1. So it would be 2. Yp would be z plus 2 in terms of z. Now y is equal to yc plus yp. And finally, I'll transform everything to x because the problem is given to me in x. C1 plus C2z. Z is what? Z would be log x. C2z log x into e power x. E power z would be what? X. E power x would be, e power z would be x plus this z is what? Log x again plus 2. This would be my solution. This is how I will write the solution to the given problem. Okay. Yeah, next problem, next video, we will see one more problem on Cauchy Euler.